Swayam Prabha. Digital India. Educated India.
helping us. Not only laser based additive manufacturing is helping us, the laser based cutting, laser based joining, all these are the rapid prototyping techniques are helping to develop the prototypes in a rapid way. So, because we have seen that lasers are very much useful for the rapid production, for producing the objects either individually or in batches. After documentation, the data will be given to the process planning team, then all the production related operations would be carried out, such as the production planning, design and procurement of new tools if the tools are not available with the industry. We have to order the newer materials if required, and generation of new CNC and NC codes, which we have seen in previous class. Then actual production would be carried out, then we have to carry out the quality control or quality assurance. Here the lasers are helping us. So, we can even find out where the lasers are helping. For inspection and quality control, lasers are useful. For laser based in production operations, lasers are helpful in material removal, joining, then assembly, forming and surface treatment. So, all these modules we have already seen in our previous weeks. All these are coming into the production operations, and now the lasers are also useful at the design stage as well. So, laser based design is coming into the rapid prototyping, that is a 3D printing. Then 3D laser scanning to get the data. 3D laser scanning is also very much utilized to get the data or to carry out the re-engineering of the products. Well, the lasers are further used in packaging as well, and it will be shipped to the market. So, during this conveyance process as well, lasers are used, that is laser based navigation. Right, and last is the marketing. When the product is coming into the market, the sales and marketing team will interact with the customers, they will get the feedback, and that feedback will be given to the design team. So, all these activities are getting done in a circular manner, in a cyclic way. So, that is why it is called as the product life cycle, which is starting from the design need and ending to the design need itself. Now, when we try to club these entire activities in two groups, so we can easily identify there are activities which are pertaining to design, that we call design process, and there are certain activities which are pertaining to the manufacturing. So, these are all the manufacturing related activities if we club together, and these are all the design related activities. Now, if we look at the design activities, so further we can classify them into two groups. The first one is synthesis group. So, here you can see the identification of design need, then converting the design need into design specifications, and then carrying out the feasibility study and coming with the design conceptualized model. So, all these activities are termed synthesis of the design. Well, if we consider the analysis of the model, then converting that the conceptualized model into the reality, we have to test it, we have to convert that into engineering model. So, conceptualized model may be artistic, it may not be even possible to manufacture as per the design team. So, the engineering team will look at the manufacturing aspects as well. So, we may need to modify the design given by the design team based upon the manufacturing capability available with the that particular enterprise or the company. So, the designing would be done. So, analysis of the design, optimization of the design and evaluation, this is termed as analysis. So, analysis is including the design analysis, optimization and evaluation. If you look at all these activities in a broader sense, you will find that so many activities are to be carried out either in a sequential way or in a parallel way in the industry. And carrying out these activities manually, it is an uphill task, it is very difficult. So, here the computers are helping us to automate the process. For example, conceptualization of design. So, to conceptualize the design, we have to develop the clay model. Earlier people used to have the clay modeling, or they may go for the wooden models, and then they were carrying out all the analysis over that. That used to take a lot of time, but now with the computer aided drafting or computer aided 3D modeling, we can have the digital model of our idea. It will come for the realization or for visualization immediately on your screen. Then you can discuss, you can have all sort of analysis, deliberations over that design, and then you can finalize it, which has reduced the time of conceptualization from months, weeks to days, or in few hours also you can have the conceptualized model with you. So, the same have been summarized over here. The synthesis is dealing with the philosophy of design, functionality and the uniqueness, the features of that particular design, which is at the initial stage itself, at the concept of the product is coming into picture. We have to develop a certain philosophy, accordingly we have to incorporate various functions, and we have to look for the uniqueness of the product which can be sold in the market easily. Then the analysis has to be carried out by converting the conceptual design into the model. So, here we are applying all the engineering science based principles to get the required conversion. Now, what is the scope of CAD and CAM? So, the CAD is, you can say, the intersection of three disciplines: the geometric modeling, computer graphics and the design, that is a mechanical design. So, to develop or to have the expertise in CAD, we must have the knowledge of computer graphics, knowledge of design, that is a mechanical design and modeling. As far as computer aided manufacturing is concerned, it is the intersection of computer aided design, automation and the manufacturing operations or manufacturing processes. So, to become a CAM engineer, he or she must know about the CAD related softwares or CAD related technologies, various manufacturing processes which are being used in the industry and the automation technologies. So, well, there is another definition of the CAD as well. So, here we are defining the CAD as the integration of computer science techniques pertaining to the computer graphics and optimization for the engineering design. So, to design the parts by applying the engineering principles, but to realize them, to visualize them on the screen, we should also know the computer graphics. So, there has to be integration of the computer science techniques for the engineering design. The CAD has the requirement of hardware as well as software. So, hardware in general, that we know that we require a lot of input devices and there is a need of the output devices as well. Without that, the CAD system is helpless. It is not only the hardware, there is a strict requirement to have a modeling software as well. Modeling software is an integral part of the CAD CAM system. The software is a group of programs which is helping us to carry out the modeling and analysis of the 3D models. Then there are a lot of techniques or methods which are being used, which are mathematical techniques such as matrices, differential equations and various optimization methods. Now, let us see what is the meaning of 2D CAD drafting. So, in the 2D CAD drafting, we are generating various 2D shapes, two-dimensional shapes, which are made up of lines, curves and arcs. So, we are arranging these lines, curves and arcs in a very logical way, and by looking at this 2D drawing, one should understand, or it is a way of communication, it is a language of interpretation, it is a language of communication with your subordinate or with your boss or with your team members. In 2D CAD drafting, we are generating 2D drawings which are made up of lines, curves and arcs, and these 2D drawings are giving us certain information. The information is about the shape and size of the product, but it is in a 2D format, two-dimensional format. So, to give all sort of information about the product, we may need to have more than two views of a particular product. So, we have to go for the orthographic projection. So, there are simpler 2D modeling techniques, that is the orthographic projections are being used in the industry. Computationally, this 2D drafting is inexpensive, it is cheap, it is not time consuming as well. However, the 2D models or 2D drafting entities are not giving the realistic view of the product. So, on your screen you can see a 2D drawing. So, here the dimensions are provided. So, here you can see a drawing which is made up by the straight lines and the circles, and certain dimensions are given here. So, based upon the dimensions, one can easily interpret or understand the shape and size of the object, and based on that the intended operation can be carried out. In 2D drafting and modeling, even we can reveal the internal shapes, internal features by following certain conventions, and that is called as the machine drawing. In machine drawing, there are a lot of conventions, and this, by applying these conventions, we can easily communicate about the internal shape. Now, here you can see this is the hatch lines, and these hatch lines are designating that some portion has been removed, and after removing the portion, this is the shape that we are getting. Wherever the hatch lines are not there, that portion is uncut portion. So, this is the uncut portion, or it was void. So, there was nothing over here, that is why there is no hatch lines are given. So, there are a lot of other conventions we are using, such as the dimensions. So, this is the indication of the diameter, that is phi. Well, by applying all these conventions and by using the geometric entities such as lines, curves and arcs, we can create the 2D drawings. But as I mentioned you, the visualization is difficult in 2D modeling. So, that is why we have to go for the 3D modeling. So, in 3D modeling, there is better visualization. So, we are generating the solids. As we know that solids are having surfaces. So, consider we are having a cube. So, this is a 3D model, and it gives the realistic view. So, if we consider the 3D model, so it is made up of the surfaces. The cube is having 6 surfaces. So, consider this is the face 1. The face 1 is nothing but a area bounded by certain curves. So, here the lines are there. So, by using the lines, we are getting a certain shape, and that is the face 1, it is a square. Now, this square is made up of lines, line 1, line 2, line 3 and line 4. Now, these all lines are having 2 vertices. The vertices are V1, V2. In a similar way, we are also having vertices for line 2, 3 and 4, and each vertex is having x, y and z coordinate. So, if I try to develop a inverted tree, then I can say that we are getting a solid. The solid is having faces, so the face 1, face 2, so on and so forth. The faces are having boundaries or curves or lines. The most appropriate word is edge, edge 1, edge 2 and whatever the number of edges it has, say n, number of faces are m. Now, each edge is having endpoints. So, endpoint I can call vertex 1 and vertex 2, and each vertex is having 3D coordinates x, y and z coordinates. So, this is x1, y1, z1. Similarly, we are having x2, y2, z2. So, this is the inverted tree representation of a 3D solid model. So, to define an object, we should have the information about the solid, and solid can be manufactured or can be developed by giving the information of faces. Faces can be developed by giving information in terms of its edges. Edges are defined by giving the information in terms of the vertices, and vertices are defined by its coordinates. So, to develop a solid model, we should have all this information ready with us, and then we can go for the utilization of 3D CAD modeling softwares. Well, the solid modeling is again having various other paradigms where we can represent the 3D solid model. We can have the wireframe model. So, here in the wireframe model, we are not providing any volume or we are not providing any surface, it just the vertices, and these vertices are connected by the edges. The wireframe models are light in weight as far as the memories are concerned, but they are difficult to interpret, difficult to visualize. So, simple wireframe models are useful for analytical computations only, but for visualization we have to go for the 3D solid models. So, this is the 3D solid model. To this 3D solid model, we can attach various materials, we can render them by attaching various materials, we can apply texture on these models as well. We can apply the lighting systems, illumination to give more realistic view to that. Surface models also can be developed. These are the surface models of the car skin. So, modeling, it is having two paradigms, that is the 3D solid modeling and the surface modeling. So, few more examples are there on your screen. So, here you can see this is automotive model, then we are having the furnitures, and these are the 3D models, and these are for the animation industry, animation or the entertainment. So, here the gamings are also comes, so games are also part of this. Fine. So, to have the proper visualization or the display, so we have to display the objects on the 3D screens, and when we put the models on the 3D screen, we have to map them properly, that we call mapping of the developed model on the screen coordinates. We can apply shading, we can even remove the hidden surface that is coming into the surface modeling or surface geometric modeling. Then by applying various projection techniques, such as the orthographic projection and the perspective projection. So, perspective projection is giving us more realistic view of the object. It is a bird eye view basically being used in the architectural drawings. So, which is giving more realistic view. The orthographic views are the 2D views, and to provide the knowledge or to give the information about the part model. In orthographic projection, we have to use multiple number of views, and that is the drawback or the limitation of orthographic views. It is difficult to understand or visualize. What are the application of CAD and CAM? So, the CAD and CAM techniques are useful in mechanical, electrical, civil and architectural engineering. As far as analysis is concerned, we can carry out the stress analysis. So, for that purpose we are using a technique, and that is called as the finite element method technique. So, to carry out the deformation analysis or the temperature analysis to solve the heat conduction problems, we are using this finite element method, but the basic input to the finite element method is CAD drawing itself. Consider you have to find out the stresses which are developed in the laser based forming, or consider you have to find out the residual stresses which are generated during laser based material removal. So, to sort out these problems we are taking help of the finite element, but to have the proper finite element analysis, the 3D model has to be generated. The deflection, then the numerical simulation and the animation. So, consider if you want to carry out the animation of the movement of various linkages inside a mechanism, there also the CAD drawings are very much useful. To even find out the optimal levels of the parameters, particularly the sizes or the thicknesses of the various elements of a product, the CAD modeling is essential. Now, let us see or have a look at various input output devices which are being used in the CAD. So, we are using the mouse, which is very basic element. We are also often being used when we are dealing with the computers. The earlier mouse technology was based upon the potentiometer or sensible variable resistors, but nowadays we are using optical mouse and the wireless technology. Even in CAD industry or in animation industry, the trackballs. So, trackballs here, by maneuvering this sort of balls, we can even change the location of pointer on the screen, or we can use the joysticks. Again, joysticks are being used to change the pointer location on the screen. Then light panes. So, these are the digital panes which are working based upon the infrared technology, and even we can select or pinpoint a particular location on the display. So, by using light sensitive diodes, we can pinpoint a point on the screen, and based on that we can carry out variety of CAD related operations. In addition to this, we are using tablet and pen, and these tablets are having the pens which are emitting signals of certain radio frequency, and the tablet is having circuitry beneath the screen, and when the pen is touching to a certain point, at that point the frequency will get sensed, and that location will be recorded by the microprocessor system. So, these are some of the applications, particularly the tablets and pens are used in animations. So, you just notice these are the applications of developing various animated characters. As far as the output devices are concerned, the prominent output device is the display device, that is the monitor, the display monitor, and based upon the pictures or the images that we are getting on the monitor, we are visualizing them. So, it is very essential for us to select a proper monitor. So, nowadays we are getting all the advanced monitors or advanced display devices which are based upon the liquid crystal display, that is LCD, or light emitting diode display, that is LED. But earlier people used the CRT, that is the refresh CRTs basically. So, this is a particular arrangement of the CRT. So, here the CRT screen is having the phosphor coating and we are using an electron beam. This electron beam is focused on this coated screen, and wherever it is getting strike, that much portion is getting illuminated. So, then by maneuvering the electron beam on the screen, we can create variety of images on the screen. Now, to create that image on the screen, we have to use a huge picture memory and a refresh buffer, and the refreshing speed should be at least 60 to 80 times per second. So, here you notice that the electron beam is moving over the screen in a raster way. It is starting from the top left corner and then it is moving in a zigzag manner. So, wherever it is applying the intensity, that much portion is getting illuminated. So, in this way the pictures or the images are created on the CRT screen. Now, when we are having 3 different electron beams of 3 different colors, that is a RGB, red, green and blue, then we can create the colored images as well. Then recently we are using the flat panel displays. So, these flat panel displays are having reduced volume, their weight is also reduced, and certainly it is saving a lot of power. So, instead of handling a very big device, that is a CRT device, we are using a very thinner display devices, and these displays are emissive displays, that is the plasma displays and LED displays. There are certain non-emissive displays also being used, and these are the LCD, that is a liquid crystal display. Now, what are the various output devices being used in the CAD industry? So, particularly the output device is printer or the plotter. So, printer, the size is comparatively very small, but the plotters are having a very huge size, and by using these printers and plotters we are communicating the developed design, developed models with the team, and then we are acting upon the drawings further for its production or the manufacturing. So, with this brief note about the CAD and its utilization or its importance in the perspective of laser based manufacturing, we have seen the CAD and CAM systems are playing a vital role in development of a laser based manufacturing system, because all the systems are CNC based and CAD technology is very much essential to know about. Then what are the various 2D and 3D modeling techniques being used, what are the various input output devices being used, we have seen them in a very introductory level. So, the details about these are out of scope of this course. We have also seen the hardware requirements for the CAD, even we have seen the applications of CAD and CAM in detail during our discussions. So, applications of CAD in general that we have seen, and in laser based manufacturing particular, in the laser based manufacturing as well we have seen the applications of CAD. Well, with this I would like to stop for today's class and this week as well. Thank you for watching this video. Goodbye. Thank you.